Hello everyone. Let us start with some new topics on geotechnical engineering. So we'll start with a topic which is called as activity. And the formula for activity is plasticity index, IP, and percentage by weight, actually percentage by weight finer than 2 micron. Percentage by weight finer than 2 micron. That means if it is a sieve, okay, there is a sieve and the sieve size is 2 micron, and suppose 1 kilo of sample you are using, suppose you are placing it here, and suppose 200 gram passes through the 2 micron sieve. Suppose 200 gram passes and 800 gram gets retained. That means what is the percentage? So percentage is how much? 200 by 1 kilo means 1000 gram into 100, which is equal to 20%. So like this. Okay, so whenever suppose you have a soil, and this is for clay. Activity is generally for clay soils, and percentage by weight finer than 2 micron. When you get the clay soil, when you sieve it, you will get this value, and plasticity index you will get from the liquid limit and plastic limit, from the liquid limit and plastic limit tests. Okay, so what is the basic significance of activity? So um, if I write the definition, if activity is higher, then we can expect clay-like behavior, like higher compressibility, higher swelling and shrinkage characteristics from soils. Okay, so you can just write the note: higher activity, it means higher, if a soil has higher activity, it means the soil will have higher and pronounced clay-like behavior, then higher compressibility, higher compressibility, then higher swelling and shrinkage characteristics, higher swelling and shrinkage characteristics. Okay, so there are some ranges, is very important. If the activity is less than 0.75, then we can say that the soil is not that active, so we can say it is inactive. If it is between 0.75 to 1.25, then we can say that it is like active in a normal way. And if it is greater than 1.25, then we can say that it is like, we can say it is very active. Okay, so these are the things that you need to know about activity. This is enough that you need to know. Now let us go to another topic, which is called as compaction of soil. Okay, so um, let's write it down. Compaction of soil. So what does it mean? What does it mean by compaction of soil? It means the densification of soil by the application of mechanical energy is known as compaction. Okay, so densification of soil by the application of mechanical energy. Mechanical energy means what? Energy applied by hands or machines. Okay, application of mechanical energy. This is known as compaction of soil, and this is a very important way of what? Soil improvement, because when we compact the soil, then the soil becomes more strong and it can carry more loads, isn't it? So it is a very important type of soil improvement. And there is another term which is called as consolidation, and compaction and consolidation are not exactly same. So consolidation is not equal to compaction. There is a huge difference between compaction and consolidation. Uh, in consolidation, what happens is that uh, there will be volume reduction. Okay, there will be volume reduction. So let us now try to find out, write down the differences between these two point wise in the form of a table. Okay, so let us make a table, and point wise let us write down the differences. So on the left side I will write for compaction, and on the right side I will write for consolidation. So for compaction, first one, it is instantaneous. Genius. And for consolidation, it is time dependent, because that means consolidation, it happens for a very long time. It is not instant. So compaction means, suppose this one is the soil. Okay, we apply mechanical force on the soil, and instantly the soil gets compacted. Okay, so instantly the soil gets compacted like this when you apply the load. Initially it was like, suppose here, now it is this one. Okay, so instantly it gets compacted. Now consolidation, it's not instant. Okay, it happens over a long period of time. Okay, it's not instant, but compaction is instant. And consolidation is not about applying mechanical energy. Okay, applying mechanical energy like this one. Consolidation is not related to applying mechanical energy. Compaction is applying mechanical energy, and instantly when you apply the energy, the soil gets compacted. Okay, so that is the first thing. Okay, so let us go to the next one. Number two, soil is unsaturated. Okay, and here the soil is saturated. That means in consolidation there is no air. Okay, there is no air. There is like air is totally expelled. Okay, and number three, the compaction happens due to reduction in the air voids. That means you see, suppose this is the soil. Soil is a three-phase system, you know. So it is soil, air, water. So when we apply the load, what happens is that this air, it gets reduced, it gets expelled. Okay, so ultimately the soil volume changes. So this is the phenomena for compaction. Okay, so you can write for compaction here. It is due to the due to the reduction in the air voids. Okay, it is due to the reduction in the air voids. And number three, in consolidation, uh, it is due to expulsion of water. Means when there is like, first this is the soil sample, air is there, water is there, then solids is there. So when there is compaction at first, then air will go, move out, isn't it? Air will leave, so volume reduction happens. Then in a long duration of time, what happens is, yeah, when there is load over it, okay, there is load over it. Suppose there is some load over it, okay, over the soil, there is some load, okay, load over the soil. So with time, what happens is the water gets expelled. Okay, the water goes out. Okay, if we place a load which is like, which will be there for a long time, this load over the soil will be there for a long time. Okay, long time. So water will get expelled and then the volume will decrease. So that is the phenomenon of consolidation. Okay, that is the, and it is time dependent because with more time, more water will get expelled. That's why point number one for consolidation is time dependent. With more time, more water will get expelled. So number three, you write volume reduction is due to expulsion of pore water. Okay, so these are various differences. Then compaction is one difference is you no need to write it here. It's we have already discussed. Compaction is due to what? Compaction techniques. Okay, that means if number 4 you need to write, you can write it like there are some mechanical techniques using machinery. You can do the compaction. Okay, so techniques like mechanical machinery. Okay, mechanical techniques to compact. Okay, now consolidation is due to a sustained load over the soil. That means the suppose this is the soil. Suppose there is a house over it. So this house will be what? It will be a load for a very long duration, isn't it? So this type of loading is considered for consolidation. Okay, we don't do consolidation using some mechanical techniques or machines. We don't do that. It is due to permanent loads, okay, over a long period of time, which are placed over the soil for consolidation. Okay, and compaction is very short duration, instantaneous using machines. Compaction. So I hope you were clear with it. Now I have told you that compaction is one way of soil improvement. We cannot wait for consolidation, isn't it? Because consolidation takes years, isn't it? Consolidation will take years. Compaction is instant. So if we instantly want to improve a soil, we have to do what? We have to do compaction because it gets instant results. So what are the benefits? It leads to increase in shear strength, increase in shear strength. Then this is number one. Number two, uh, it improves the stability and bearing capacity. Stability improved. Okay, then improvement in bearing capacity. Bearing capacity we'll learn a little later. This is related to design of foundations. Bearing capacity is related to design of foundations. So this will be learned later. Now uh, it also reduces the compressibility and permeability of the soil. Okay, it means the soil will not undergo more volume change. This is the compressibility and permeability of the soil. Compressibility, permeability of the soil reduced means what? Suppose this is the soil, air, water, then solids. When you do the compaction, then what will happen? Air will go out, isn't it? So volume reduction will happen. But you see, air may not completely 100% air may not go out. Okay, even if 80% air goes out, still it is compaction. Compaction may not lead to like all the air going out. It depends on how much force you are applying in compaction. The more the force you apply, the more is the amount of air getting expelled. Okay, so the more the force you apply, the more the air will be expelled. Some air may be left. Okay, some air might remain. Okay, so since suppose at one point of time the air is now this much. Okay, the air is uh, from initial conditions. Suppose the air was here, now the air is this much, just this. That means what? In future, when you suppose air is only this much, so in future when you will be again doing compaction or some load is applied, then there will be not much of a volume change. Okay, there will be just little volume change with the expulsion of this much of air. Okay, so reduction in compressibility, so more compressibility will not happen in the future. So that is good, isn't it? If there is some load over here, then the soil will not uh, undergo much of a volume change under the load. Okay, the soil will not shrink much. Okay, and permeability means what? Now air is going out means what? Voids are reduced. Okay, air goes out means voids are reduced, and if voids are reduced, that means what? Water will not be able to enter the soil. Water enters the soil through voids, isn't it? Now, if voids are less, when you reduce the voids by compacting, there is no scope for water to enter the soil. So that's why we can say that compaction reduces the permeability of the soil. Now, how do we measure the amount of compaction? So the amount of compaction is measured by dry unit weight. Okay, so you can write it down. Degree of compaction is measured in terms of dry unit weight. In terms of dry unit weight. So you know the formula of dry unit weight. Bulk unit weight by 1 plus moisture content. So this was the formula. Okay. Now, what are the factors that affect the compaction of a soil? So factors affecting compaction. Factors for compaction. So here this topic becomes a little interesting. If you are developing interest in this topic, then this part will develop more interest in you. So what are the factors that affect compaction? You see, let us take the factor of water content. Okay, water content affects compaction. Water content, it affects the compaction. How? Now say if this is a soil sample, let me take another screen. This will be much more better. So suppose this is a soil sample, and the particles are like this, soil particles. Okay, now what will happen if the water is low? If water is low, take this concept as a story. Okay, just think of it as a story. This is very important. Start of the story is, if water is low, what will happen? When you are applying compaction to it, suppose you are applying mechanical pressure to this soil sample for compaction. So you are applying mechanical pressure to this soil sample to compact it. And if water content is low, then what will happen? The soil particles will offer resistance. The soil particles will offer resistance. Offer resistance. Okay, now you increase the water content. Increase the water content. So what will happen? The water will be like this, isn't it? Water will be like here and here, isn't it? It will be attached to the surfaces of the particles. When we are increasing the water content, the water obviously it will be absorbed in the particle surfaces, isn't it? The water, it will be absorbed in the surfaces of the soil particle. Then there will be what? There will be lubrication. Because of water, there will be lubrication in the surfaces of the soil particles. So when there will be lubrication in the surfaces of the soil particles, thus then you when you apply the mechanical load, mechanical when you apply mechanical energy, the soil will try to rearrange themselves. Means I will show you the modified version. When you apply the mechanical load now, the soil will try to rearrange themselves in what? It will try to, like, it will move closer to each other. Okay, and they will try to get together in a denser configuration like this. The soil particles will move closer due to some lubrication. The soil particles will arrange themselves. It will move closer to each other like this. It's all due to the lubrication effect. Okay, so that means what? There will be more, what? More dense. It will be more dense, and ultimately the compaction will be high, isn't it? Ultimately the compaction will be high, and compaction will be high means what? Dry unit weight will increase. You can just think like this, that compaction is proportional to the dry unit weight. The more, like, if your compaction is more effective, then dry unit weight will increase. Okay, if your compaction is more effective, then dry unit weight will increase. More the compaction, more the dry unit weight. So this is how it is happening. Okay, at first particles will offer resistance, then add more water, then there will be lubrication, then particles will try to rearrange themselves in more denser configurations, and ultimately the dry unit weight will increase, with leading to the increase in compaction. Okay, and let us now go to the last stage. let us now go to the last part. What happens? This is the second part. Okay, so this one is the first one, this one is the second part. So what happens in the last part, part 3? So part 3, adding more water. If I are adding more water, still more water, then what will happen? The water will start to replace the soil particles. That means if this is the soil, the water will try to take more space. Okay, water will try to take more space, and the soil particles will again get separated from one another. Water will start taking more space like this, and ultimately the soil particles gets more separated from one another, and ultimately the compaction reduces. That means compaction reduces means dry unit weight decreases. So this is the basic story. Okay, so if I add a water content, if I keep adding water content, and if you look into the dry unit weight, which actually signifies the compaction, then at the very beginning when you are adding water, so what will happen? There will be lubrication, particles will start rearranging themselves, and more denser configuration will happen, and highest level of compaction will happen at one point of time, and that means there will be high dry unit weight. And then this is from here onwards, stage 3 will start. So in stage 3, the again the dry unit weight starts falling, because the particles, the water is trying to replace the spaces of particles, and the particles are moving away from each other. Okay, so that is the way it happens. Okay, this is the first one, then here is the second stage, and here is the third stage. Okay, so it is like a story. Think of it like a story.